Okay, so we're back now. So 9 lots of a quarter, right, well, let's think about that then. So in every one whole, I have 4 quarters. I want 9 lots of them, so we go 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 quarters. I just want 1 more quarter, and there we go. So I've got my answer to what's 9 lots of a quarter. I've got 2 wholes and 1 quarter left over, so I can leave it as that. 2 and 1 quarter, a mixed number, okay? Or if I wanted my decimal back, well, we know my 1 quarter is 0.25. So I could write this as 2.25. So there's my 2 and my quarter, okay? So I hope you didn't get too lost in that, but I think it's really worthwhile being able to flip between fractions and decimals and be able to picture exactly what we mean when we're timesing something by a decimal. Okay, so list all the factors of 30. So factors, I've spoken about them before as well. 2 numbers which multiply together to make that number 30. Okay, it's always nice to have a list that increases on one side and decreases on the other. So what do I mean by that? Well, here's my first 2 factors of 30, 1 and 30. And then, okay, so next factor, 2 times something. Does 2 go into 30 because it's an even number? So in fact, 2 times 15. So there's another 2 factors. Keep going. Does 3 go into 30? Yes, it does. How many times? 10. I've got 3 and 10. 4 doesn't. You could test that. You go up in 4 times table. 7 times 4 is 28. And then 8 times 4 is 32. So that doesn't make 30. 5 does go in 6 times. Okay, so we've got 5 and 6. Now, how do I know I'm finished? Well, if I made this number bigger, it would then become this number here. So I've already got it. And then as we switch the numbers over to these getting bigger and these getting smaller, we would just end up with the same numbers on the other side. Okay, so our list is complete. We've listed out my multiplications to make 30, and therefore I have all my factors. Right, work out the size of the missing angle. It's a bit of a naughty question, really, because there are actually 3 angles here. There's this one here. There's actually this one here as well, which is perfect because this actually helps us to answer the whole question. So what we have here is a straight line, and if we took a protractor, actually, you know what, I think I'll get one out. Okay, so here's my protractor here, and as you can see, I put it here where the 2 lines meet, so right in the center of my 3 angles. And down here you can see a number that says 0, actually it flicks to 180 really quickly. So if I start measuring round in my protractor from here, so I'm going to follow the line I've drawn there around all the way to the side. So here we go. So that number getting bigger and bigger and bigger as we go around. And in fact, if I measure on my protractor an entire straight line, I end up with 180 degrees. Okay, so we can get rid of that for a second. So on a straight line, we have 180 degrees. And I think this is the angle they actually want us to measure. So here we have 180 in total, and we have 180 in total on this side as well. We've in fact broken our 120 up, and one of the parts is 47. So then the question is, what is my other part over here? So my other part will come from doing, well, I've got 180 in total, but I've already used up 47 degrees. Okay, so these degrees is our measurement for our angles. So now I need to do 180 take away 47. Now, if you were doing this mentally, I would do 180 take away 40, which takes me down to 140. Then I will take away 7, which gets me to 133. But we can do this way as well. So 0 take away 7, have to borrow. So this goes down to a 7, this becomes 10. 10 take away 7 is 3. 7 take away 4 is 3. And then 1 take away no hundreds there. Oh, is 0, so it's 33. Sorry, it's 133. 1 take away nothing, 133. Okay. Right, let me just clear up the screen. Okay, right, so cross that one off. Question 8, round to the nearest 1,000. Okay, so let's first say the number. So we've got 64,609. Okay, so here is our thousands column. So we've got units, tens, hundreds, thousands. I want the nearest 1,000. So we're saying are we closer to 64,000 on our number line, or the next 1,000, which is 65,000? So I've gone one up in my thousands column, okay? And my number is 64,609. Well, what's in the middle? Well, that would be 64,500. So as we can see, 64,609 would be around about here. So we're a little bit closer to 65,000 than to 64,000. But we've spoken before about that rule, haven't we? So we look into the column that we're interested in, the thousands. We look into the next one. The 6 is greater than 5. It's bigger than 5 or above, okay? And therefore we round up. So this number here is 5 or above. Then we round up the one in the column that we're interested in, as we round that 4 up to the next number, which is the 5. So we end up with the answer of 65,000. Okay, right, multiply 3/7 by 9. Now this is where earlier it was quite useful to think about fractions. So I want 9 lots of 3/7. Now we shouldn't get confused with fractions because it is just lots of, okay? And if we want lots of, we could do an addition here really to get the answer sorted in the first place. So we could say, well, I've got 3/7 and I add to that 3 more 7s, and I add to that 3 more 7s, and I keep doing that 9 times because multiply means lots of. And as soon as we've got it set out like that, we can see the rule will form. If I've got 9 lots of these 3/7, and I'll have 3 add 3 add 3 9 times, or if you like, 3 times 9. And that's 27. So I'll have 27 lots of my 7s. So I'm living in the world of 7s. So the number at the bottom doesn't change at all when I multiply a fraction by a whole number or an integer, if we use the right language there. So we end up with the answer 27 over 7. Okay, so 3/7 times by 9 is just really 9 times 3 over 7 there, or 27 sevens. Okay, and then finally, question 10, algebra. Okay, now when we've got algebra here, we've got x, and that just means a number that I don't yet know. And we're just going to call it something, which is actually where it's derived from. So x actually means something, derived all the way back from Arabic. So what's something add 8 equals 27? Well, we can all do that, okay? So we can probably guess at what that is. So 19 add 8 equals 27. How else could I have got to that answer? Well, if something add 8 is 27, if we do the inverse operation, to get back to where my something started, I start my 27, I lose that 8. 27 take away 8, let's go back down. And the answer to that again is 19. And there we go. Okay, so well done if you got all of those right and you watch that through to the end. And again, if you get them all right, have a go at the advanced, and excellent work for working through some holidays at these questions. And I look forward to seeing you in week 5.